So let us see what we are going to expect in paper 5. For me, I think paper 5 is actually easier than paper 3. Okay? It is more of analysis and more of making a graph plot and calculation. So for paper 5, the time allowed is 1 hour 15 minutes. So again, the time is quite tight. You have to actually know exactly what you are going to do or how you could approach this paper. So it is again 2 questions. One, which is question 1, is kind of analysis. You are going to be given a scenario for an experiment to investigate. Okay? So question 1 is you are going to be given a scenario. Okay? You are going to be told how some physical parameters are kind of related and how we can investigate how 2 of the parameters are related mathematically, okay, or related physically. In this question, you are going to be given a mathematical formula, okay, something like this. Can you see it?
Yes.
Okay. You are going to be given something like this, and you will be asked to write, okay, or to detail how you are going to carry out the experiment. Okay? It is quite easy. I'm going to show you how you can approach this question, okay, or how you can put steps to answer this question, okay? So this is the first question. You are going to write kind of a scenario, how you are going to carry out the investigation, and how you are going to analyze the results. So this is all about question 1. There is no calculation. There is nothing like this, okay? Second question,
Okay.
you are going also to be given another scenario for an experiment and how some physical parameters are related, okay? And you are going to be giving some results or data, like can we see here on the table? You are going to make a graph plot, but now our graph plot is a little bit more involved. It is a little bit more difficult than we did before. The good thing about the graph plot here, that he's already giving you the scale. You don't have to pick your own scale, okay? Can you see it? So in this one, he's going to give you the graph, the scale for the X and Y axis. So what is different in this one? Actually, the difference is going to be in the table. We are sorry, we are going to complete the table, but we are also going to calculate significant figures. Sorry, absolute uncertainties. We are going to calculate what? Absolute uncertainty.
Certainty.
Okay, so this is going to be something new. Can you see this calculation over here, for example?
Yes.
Okay. Now, we are going to use this information to make a graph plot. Can you see this graph plot? Does it look different than what we used to, or let me zoom in. Can you see? Does it look different? What do you think the difference
yes, it
is?
does. There's 2 lines.
2 lines, okay. What else? Can you see any other difference?
The coordinate.
Yes. Do you see how we are presenting the data points? It is not anymore like a cross.
Yeah.
It is a cross with something else, right?
Yes.
Okay. And this something else, we get it from the data or the absolute uncertainties. Okay. We are going to go through that, but I'm just would like to tell you what you should expect in this paper. Okay. And we have two straight lines. We have two straight lines. Okay. Then you are going to calculate the gradient. You are going to calculate the intercept. You will be given an equation, and you have to compare this equation to that of a straight line, as we did before. But this time the equation is going to be more involved. Okay? And we are going to decide what is the gradient, what is the intercept, and then we are going to do some further calculation. Okay?
Okay.
Okay. And it always be calculating also absolute uncertainties or percentage uncertainties. Okay, so we are going to do a lot of calculation for the absolute and fractional or percentage uncertainty. So this is what we should expect in this papers. Okay, is it fine?
Okay.
Okay,
Yes.
good. Okay, so let us get going a little bit more further. So when I was telling you about absolute uncertainties, what did you make sense of it? What does an uncertainty in a measurement would mean for you, Dean?
It is like an error.
Kind of an error. Or better say, when we make a measurement, we are always not quite very sure how the value is exactly, right?
Yes.
And let me give you just this quick example. Let us say we have this meter ruler. Okay? It is marked as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 1 centimeter. 1, 2, 3, 4, 5, 6, for example. Okay, so we are starting from 0. This is 1 centimeter. 1, 3, 4, 5, 6, so on and so forth. So if we have a measurement of a length of a wire, okay, and we start from 0, right? And it goes all the way up to here. This is our wire. Okay, what is this length of this piece of wire?
0.9.
We
98.
can say it is 0.9 maybe, but we could also say it is 1, right?
Yes.
Okay, it will depend who is making the measurement or how are we going to decide. So we could say it is 0.9. I could say it is 1, right? Is that right?
Yes, it is.
Okay. What if the line was over here, Dean? Can you see this one?
Yes.
Okay. How much are we going to report for the length?
You can say 1 or
Okay.
1.1.
Okay. We can say it is 1 or 1.1, right?
Yes.
So can you see this measurement of 1? When it is a little bit shorter than 1, we could say it is 1. And when it was a little bit longer than 1, we could also report it as 1. Right?
Yes.
So whenever someone is telling us the length is 1 centimeter, we are not quite sure. Was it 0.9 and closer to 1? Or was it 1 and close, or was it 1.1 and but closer to 1, right? We don't know which scenario it is, right?
Yes.
It could be this one or that one,
Right.
right? So in each measurement we take, we are always kind of a little bit uncertain, right?
Yes.
Okay. And this uncertainty is going to lead us into, when we do the final calculation, the final measurement, we are also a little bit uncertain. Okay? The final calculation,
Okay.
the final result of any measurement is also going to be a little bit uncertain. It is always important to account for the uncertainty. How much I am not sure about my measurement. Okay? Now, I think previously we have learned, or you have seen, if we have two measurements, like the area is equal length times height, right?
Yes.
Okay, this is an area. And if I ask you, I have the uncertainty in L, which is delta L, right? I have the uncertainty in H, which is delta H. Is that right?
Yes.
Can we calculate the uncertainty in area? Delta A?
Yes.
How?
Delta L
Okay.
over L plus delta H over H.
It is going to give us what?
Delta A.
It's not delta A. Delta A over A, right?
Oh, yeah.
Okay. Delta A over A is going to get is equal delta L divide L plus delta H divide H. Okay. Very good. What if the density is the mass divide volume? I know delta M and I know delta V. Can we get delta rho?
Okay. Delta rho over rho equals delta M over M plus
Sorry.
delta V over V.
Exactly. This is good. Okay. What if our physical quantity is L, the extension, is equal L1 minus L2. We know L1 and we know L2. Delta L1 and delta L2. So what is the error in the uncertainty in delta E?
Equal delta L plus delta L2.
Delta L1 plus delta L2, right?
Yes.
Yes, this is very good. And if it is also, there is something like the C.
Plus delta C.
Plus delta C, exactly. Very good. So now our calculation is going to be a little bit more involved. Okay? When we are calculating this kind of uncertainties. For example, if I tell you A is equal B to the power N, how can we handle that?
Delta A equal N multiplied delta B.
Not really. Think of it as B times B times B N times. Can you think of it this way?
Yes.
Okay, can we? Then what is going to be?
B multiplied Bn.
No. Why don't we think like this? They are multiples, right? So delta A over A is equal delta B over B plus delta B over B plus delta B over B N times. So what is going to be? Is that right?
Yes.
Okay. So we are going to learn very basic, okay, basic formulas to calculate the uncertainty, but they are going to be more involved and more complex. For example, what if I tell you that, for example, T is equal A times B divide C plus K. T is equal A plus B divide C plus K. And I know all the uncertainties, delta A, delta B, delta C, and delta K. Can we get delta T?
Delta T over T equal delta A over A plus delta B over B plus delta C over C plus delta K.
No, no, and yes. Let us see. So we are going to divide it into two parts. This part and that part. Okay? We are going to divide it into what? Two parts.
Two parts.
Okay. Let us do the first part. So delta T over T is equal, as you say, delta A over A plus delta B over B plus delta C as divide C, right? Is that
Yes.
okay? Is that okay, Dean?
Yes, it is.
Okay. What about the second part?
Plus delta K.
Delta K, delta T is equal to delta K, right? Is it okay?
Yes.
Okay. Now we have to add them together. Can we directly add this one to that one? Can we, Dean?
I think yes, I'm not sure.
No, we cannot, because this is delta D over T, and this is only delta T, right? You cannot add two different physical quantities together, right?
Yes.
So we have to a little bit modify this one. How we are going to do that?
What did you say?
So we have to modify this one a little bit.
Multiplied by T.
Yes, exactly. Then we have delta T is equal delta A divide A plus delta B divide B plus delta C divide C and multiply by T.
Multiply T.
Now this is delta T and this is delta T. We can add them together. We are now fine.
Yes.
Okay, plus delta K. Okay? Can you see how we are
Okay.
proceeding?
Yes.
Even things, if they get a little bit complicated, then we are just going to break them into smaller pieces, okay? And do each part
Okay.
and see how we can join them together. Okay. Sometimes you get things like ln of a function. For example, ln x. And I know delta x. But I would like to know what is the error in delta ln x. So how should I do that? Okay, this is how you do it. If, for example, you are given, you have a value for x, 5.0 centimeters, okay, and they are telling you delta x is 0.1 centimeter. And you were asked to calculate ln x and the error or the uncertainty in delta ln x. So this is how you should proceed. Delta ln of x is equal, very simple, ln x plus delta x minus ln x minus delta x and divide by 2. Okay? Always remember this equation, team. Remember this one for the ln function. Okay?
Okay.
Okay. So how we are going to do that? It's going to be ln, what is x?
5 centimeter.
5. Okay. What is delta x?
0.1.
0.1. Minus ln, what is x? So what is x, Dim?
5.
Sorry?
5.
5 and minus delta x, right?
0.1.
So it is going to be ln 5.1 minus ln 4.9 divide 2. Then we do the math. So it is ln 5.1 minus ln 4.9 divide 2. So it is 0.02000. 0.02. And we always keep the uncertainty to one significant figure. Okay?
Okay.
Does the ln have units?
No.
No. Okay. Do you know what is the difference between the ln and the log?
No, I don't.
Okay. The log of a function, okay, it is always related to powers of 10. To the powers of 10. For example, if you were told that a is equal 10 to the x, 10 to the x, okay, and the function that we can use on this equation, it is going to be the log function. Why? Because we have power of 10. Do you know how we can apply a log function on this one, on this equation?
I will make a shift log.
Sorry?
I will press shift in the calculator, then log.
No, no, no. How we can, if I want to write this equation using the log function, rewriting this equation using the log function.
No, I don't know how.
Okay. Then you apply the log function on both sides. This is very important. So you say log A equal log 10 to the power x. Okay? Now, from the rules of the log function, if you have something like this, the power can go down here in front of the log. Okay? The power can go down in front of the log. So it is going to be x log 10. X log what?
10.
Okay. Do you know what is log 10?
No.
Okay, let us do it in the calculator. Log 10. It's going to be 1. Okay, so log A is equal to x. Can you see how this equation had changed? The last thing we stopped at is using the log function, or about the log function. Okay, so the log function is always related to powers of 10. Okay, for example, if I tell you A is equal 10 to the power 4. Okay? A is equal 10 to the power 4. Can we apply the log function over here?
Yes.
Okay, how can we do that?
We'll say A equal 4 multiply log 10.
No, log A. We have to apply the log function on both sides, okay? Remember this. We apply the log function on both sides. So log A is equal what?
4 log 10.
4 log 10. Okay? And what is log 10?
4.
Sorry?
4 multiply 1.
Yes, log 10 is 1. Log 10 is 1. So log A is equal to 4. Okay. So always remember this. Let us say that A is equal T to the power N. Can we apply the log function over here?
No,
Why?
because it is not 10 to the power of something.
Yes and no. It is not the power, but we can apply the log function. The log functions can work on anything. But when it is applied on 10 and powers of 10, it got this easy way to handle, okay, or easy calculation. Okay? Because can you see we have log A here, right? A is not the power of 10.
Yes.
A itself is not the power of 10. It is equal something to the power of 10. Okay? So we can also say log A is equal log T of N. Can we further simplify?
Yes. Log A equal N log T.
N log T. This is good. Okay? Now, we
Okay.
have to remember a couple of relations for the log function. So if we have A times, say A is equal B times C. Sorry. Can we apply the log function?
No.
Yes, we can. We can. There's no problem. Okay? So again, log A is equal to B log what?
BC.
BC. Okay? But for the log function, if we have log BC, okay, it is also equal to log B plus log C. Okay? So log A
Okay.
is equal log B plus log C. Okay?
Okay.
I need you to go and remember these relations, okay? Have you done the math in the A level?
No.
No, you did. Are you going just to do physics?
Physics, chemistry, and bio.
And you are not required to do the math?
No, I'm not.
So where are you going to plan to go for your for university?
I'm not sure, but probably a country in Europe.
Okay. So this is the kind of requirement. You don't need to do the math in the A level, right?
Yes.
Okay, good. But for paper 5, I think you have to remember these formulas, okay?
Okay.
What if A is equal BC plus D? How we can apply the log
Log B plus log C plus log D.
No. It is going to be log A is equal log BC plus D. We cannot do much about it, okay? Because why? Because we have, sorry, we have a plus sign between BC and D. It doesn't give us, it doesn't reduce to these additions. Okay?
Okay.
Can you see the difference?
Yes.
Okay? When the log function is coming over here, okay, it cannot divide it any further. Why? Because we have BC plus something. It could be BC plus D minus D, whatsoever. Okay? So, remember that log A plus B is not equal to log A plus log B. It is not equal. Remember this.
Okay.
Okay? And again, remember that log A plus B, AB is equal log A plus log B. Okay? What if log A divide B? What do you think?
It will be the same.
No,
Log A plus log B.
no. Log A minus log B. Okay?
Okay.
Okay. Remember these equations. What if it is log A times B divide C? Can we now write it?
It will be log AB minus C.
Sorry?
Log AB minus C.
Can we further divide it?
Log A plus log B minus log C.
Yes. Okay? So this is the log function and the rules for the log functions. What about the lim function? It is called natural logarithm. Okay. For the log, which was a special number for the log?
10.
10. Powers of 10, right? Because log 10 is equal to 1. For the ln, a special number is E. Okay? Do you have your calculator next to you? Do you have your calculator, Dean?
Yes, I do.
Okay. Can you see this E in your calculator?
Yes,
Okay. Can you press it?
I did.
In mine is shift and the ln.
What?
Can you get it? Can you get it?
Yes, I could.
Okay. Then write this ln e to the power 1.
Okay.
And say equal. What do you get?
2.718.
Okay. 2.718 something. 28218,
Yes.
this and that. So this is a special number in mathematics. It is called the natural or the exponential. E. The natural E, right? It got this value. For this function, ln E to the power 1 is equal to 1. Can you see that?
Okay.
Okay. So for the log, a special value is 10. For the len, a special number is E. A special number is E. So len
E
of E, if we can see it on the calculator,
equal 1.
did you try it? So
Yes.
len of E, sorry, len equal 1. Okay?
Yes.
Now, the rules for the len function are exactly the same as the log functions. Meaning what? If we have A is equal BC divide D. What is len A?
Len B plus len C minus len D.
Exactly. So what we learned about the relations for the log, they apply also to the len. Okay?
Okay.
So in the exam, just be careful. Sometimes he asks you to calculate the log of a function, and sometimes he asks you to calculate the len. You have to be careful. Okay? For the log, typically in the exam, they write it as like this, LG. So if it is LG, it is log. If it is LN, it is len.
Len.
Okay? And be careful.
Okay.
Those are two different buttons on your calculator. Okay?
Okay.
So why we are doing this about the log function? One theme in the paper 5, okay, is that he's going to give you sometimes an equation or a relation, and we need to change this relation into that of a straight line. Into that of a straight line. And let me go like this. If we have, for example, t, the time is, for example, L to the power half. L to the power half. Okay, Dean?
Okay.
You are giving a physical relation, and we have some constant around here. We don't, for now, we don't care. This is time and this is length, but there is a constant that will take care of the units. Or let us write it like this. Okay. Now, does this equation look like an equation of a straight line?
No,
Why?
because it doesn't have plus something.
Yeah, but the plus something could be 0, right?
Okay.
Okay, but does it look like a straight line?
Okay, yes.
How? I mean, do you know the equation? We remember the equation of a straight line, right? Y is equal
Yes.
mx
X plus
plus
C.
c. Another name for this relation, do you know what is another name for this relation?
No.
It is called linear equation.
Yes.
Do you know why we call it linear?
Because it is a straight line.
Yes, but why we call it linear? Because y it is raised to the power of 1, right? And x is also
Yes.
raised to the power of what? Of
1.
1. So the dependent and the independent variables both are raised to the power of what? 1. That is why if we make a plot of x and y, we get a straight line. Can you follow with me, Adim?
Yes.
Okay. Why do we call it linear relation? Because the
Because
dependent and independent variables are to the power 1. We don't write typically something to the power 1, right?
yes.
We just ignore this one. But we say it is linear because it is power 1. So now this relation, this is the dependent independent, this is the dependent, and this is the independent variables. Are they both to the power 1?
No.
No. This is yes to the power 1. But this is not to the power 1, right?
Yes.
Okay. So if we make a plot of T and L, we would expect something like, I don't know, something like this, which is not an equation, it is not a straight line. Are you following with me?
Yes, I am.
This is very important. Now, can we change this equation to that of a straight line?
We need to make L to the power of 1.
Sorry?
We need to make L to the power of 1.
Okay, how can we do that, Tai? How will you be able to do that?
I'm not sure.
Okay. So you might be intrigued to think that, well, if I square both sides, I can get L to be to the power 1, right?
Yes.
Okay, but what would happen? It's going to be T squared is equal to C squared, L to the power 1, right? But what did happen over here? This became 1, right? But this is T squared.
Yes.
We screw it up again. So this might not be a good way to go. The way to go, there are actually two ways. One is that we are not going to make a plot of T and L. Think about this equation as T is equal C to the power half. All of this is to the power what? 1, right?
Yes.
Okay. Can we think of it like this?
Okay.
So why don't we make a plot of what and what? What is going to be on the y-axis?
T.
T. And what do you think we are going to have on the x-axis?
L half.
L to the power half, exactly. Now, if we make this plot, it is going to be similar to that of a straight line. Sorry, it is 0. So, from the origin, okay, the gradient is going to be C. Can you see that?
Yes.
Okay. So, this is one way of doing it. Another way, we can use either the log or the ln. It doesn't make a difference for us. For us here, it doesn't make a difference. We can use the log or the ln. Let us say that we are going to use the log function. So T is equal C L to the power half. Can we apply the log function?
Okay. Log t
Yes, log t. Mhm.
equal log c plus 2 log L.
Why is it 2?
Okay, or half.
Half. Be careful. Log L. Yes, exactly. This is right. So can we write it in the form of a straight line? Can you tell me which is the intercept, which is the gradient? And
Okay. And which one?
in this
In
one?
t equal CL?
Yes, this one, this equation. Can we decide which one is going to be the intercept, which one is going to be the gradient? Which plot we are going to make? What is going to go on the x-axis?
C.
Sorry?
Okay, L1 over 2.
No. From this equation, Dim.
Okay.
Mhm.
Okay,
No.
yes, log C.
No. C is a constant. Do you remember that?
Yes.
So doesn't make sense to have log C over here because it is a constant value,
Okay,
one single value.
half log L.
Well, I'm going to say it is log L. What about the y-axis?
Log T.
Log T. So if we make a plot, it's going to come like this. So what is the gradient?
Log C.
No. The gradient is always the one in front of the independent. And what is the intercept?
C.
Log C. Okay? There's a lot of
Okay,
C's today,
so
right?
Mister,
Yes.
the gradient is the number in the front of log L or
Yes.
log of the x-axis.
Yes. Don't we write
Okay.
it like this? Y is equal mx plus c, right?
Yes.
Okay. So we have in here log t is equal log L, right? Half plus log C. So we always have to
Okay.
remember this equation. So this goes into the y-axis. This is going to be on the x-axis. The gradient is always the number in front of the independent variable, right?
Yes.
Okay. And the intercept is always this constant value,
Yes.
right? Okay. We could have also done it with the lin. I mean, instead of log, it can be like lin. Okay? And it wouldn't make a difference, right? The numbers are going to be different if we calculate log a function, a log of a value, and the ln of a value, they are going to be different. But at the end of the day, the intercept is going to be ln c, and the gradient is going to be half. So if we get, for example, ln c is equal 2.61, how can we get c?
2.61 divided.
Sorry?
2.61 divided ln.
No. Remember, how did we get this value? If we say C, it was something like this. E to the power 2.61, right? Ln C is equal to what, ln? Ln E to the power 2.61, right?
Yes.
Then we get this 2.61 in front, right?
Yes.
And we have ln E. And we know that ln E is what?
1.
1. So ln C is equal to 0.61. Then if we want to go back, this is how to go back. So C is equal E to the power 2.61. Okay, and we do it in the calculator. We do it in what?
Calculator.
Don't know, where did I move my calculator?
Equals 13.599.
Okay. So did you get that?
13.599.
Okay, good, good. So you see, for these kind of functions, he could ask you to change it to an equation of a straight line using this technique, right?
Yes.
Okay. Or he could ask you to do the log thing or the ln. It depends what he's going to ask for you. Okay. So is there any time when we have to do the ln instead of the log? For this equation, it is fine. I mean, unless he asks for something specific, then we are free to choose to do it with the ln or the log. But are we
Okay.
forced sometimes to do it either in ln or in log?
Yes.
When? When do you think that?
For example, this equation.
Which one?
The last one.
No. If the equation involves E, okay? If the equation involves E, then to ln. Okay? If it involves powers of 10, do the log. Okay?
Okay.
Okay. Let us see one example, for example. Let me see over here. Okay. For example, can you see this equation, Dim?
Yes.
Okay, can you read it?
TC minus TR
Is equal.
equal ZE
Mhm.
minus UAT over MC.
Okay, good. So he is telling us the experiment goes as we need to investigate okay. What we need to investigate is the TC and T. Can you see that?
Yes.
TC and what? T.
T.
So a temperature on one side and time on the other side. So as we can read the equation, it means that Tc is going to be the dependent variable and T is the independent variable. Okay?
Okay.
Okay. So we need to change this equation into that of a straight line. Okay? So can we see the E over here?
Yes.
Okay. So what do you think we should do?
We want to change the TC to T.
No. We have Tc on one side. This is an equation. Tc dependent variable. T independent. So we need to change this equation to look like an equation of a straight line. Can we do that?
Yes.
How?
I'll write TC equal ZE ZE to the power negative UAT over MC plus TR.
Like this, you mean? Plus TR like this?
Yes.
Okay. But now TO is over here, right?
What?
T, the time T is over here.
Oh, okay, yes.
So this is not an equation of a straight line, I mean.
No, it is not.
All need to have the power of the dependent, the power of the dependent and independent variables need to be 1. So we cannot do that.
We can use N.
Sorry?
We can use N. Len.
N? What do you mean?
I meant we can use Len.
We can use ln, right? So how to do that? Can you do the ln for both sides?
Okay. Len
Okay.
TC.
Let me write it. Ln. Okay.
Minus Len TR.
No ln. You remember when they have minus signs between them? We cannot further divide, right?
Yes.
Okay. So we have just to leave it like this. Ln TC minus TR. Okay.
Okay.
Now, what about the other side?
It will be UAT over MC Len E.
Okay.
Len ZE.
Ln Z. No,
E.
do it like this. Ln Z. Okay. E minus UAT divide MC, right?
Yes.
As a first step. Then we have Z and this one are multiplied together. Right?
Yes.
Okay. Then what is the next step? I'm going to write ln Z plus ln E minus UAT divide MC, right?
Yes.
We don't have to rush it. Now, ln z, right? We can get the whole power down, right?
Yes.
And it is a minus. And a plus, we are going to get u
Minus
a t
T
divide m,
over C.
right? Ln e. What about ln e?
What about what?
Ln e
Equal 1.
equal 1. Then we can get rid of it. Then let us reorder it a little bit. Minus u a divide m c times what? T plus ln z.
Z.
So now if I tell you, what should we plot on the x-axis and what should we plot on the y-axis?
In the y-axis, ln TC minus TR.
Yes, exactly. It is not ln TC only. Okay, it is the whole thing. What about the x-axis?
T.
T, exactly. What do you expect the line to look like?
A straight line.
Yes, but is a positive gradient or a negative?
Negative gradient.
So we expect it to look like this. Okay, what is the intercept?
Yeah. Ln Z.
Ln z. So intercept ln z. Okay, gradient minus UA divide MC. Okay?
Okay.
Can you see why it is important that we have discussed the ln and the log?
Yes.
Okay? Can you see why in this equation we had to use ln?
Yes.
Okay?
Because of the E.
Because of the E. Because if we use log, it is going to be log E and it's going to get us a number which is, that's going to be very helpful, right?
Yes.
Okay. So go through the functions again for the log, the ln. Okay. Most probably I'm going to send you a PDF file with some instructions. Some of the equations, not everything. Okay.
Mister, can you send me this file?
Sorry?
Can you send me this file?
That we use today?
Yes.
I'm going to send the video. Do you need the file also?
No, okay. I will rewatch the video.
Okay, I'm going to send the video as usual. I have been sending you a lot of
Okay.
videos. Have you taken a look at them?